In this video, we present our fourth-place solution for SpaceNet6, which was held as a part of CVPR'20 EarthVision workshop. In the SpaceNet6 challenge, the participants are asked to extract building footprints using two modalities of remote sensing data: synthetic aperture radar and electro-optical imagery. In the SpaceNet6 dataset, training set contains both optical and SAR data, while the testing sets contain only SAR data. For this challenge, we proposed a solution shown in this figure. Our solution consists of three steps. In the first step, we compute building score map using unit models. The unit models output segmentation score for two classes, the building body and building edge. Learning building edge helps the networks to learn accurate shape of the buildings and to separate neighboring ones. We used 15 unit models for average ensembling to get more accurate building score map. Then we apply watershed algorithm to the score map in order to extract building footprints as polygons. As shown in the figure, the watershed algorithm sees the score map as a topographic surface and allocate a region to each of local maxima. It helps to separate the buildings which are close to each other. Finally, we remove false positives using light GBA models, which were trained on footprint morphological features. The light GBA models were trained on the predicted footprints on the validation set of each fold. Regarding the first part, we found that EfficientNet is the best for unit encoder. This figure indicates unit with EfficientNet encoders achieve the best performance while having less parameters compared to other networks. We ensembled unit with EfficientNet B7 and B8 encoders, which achieve the best segmentation score. The all encoders in the figure were pre-trained on ImageNet. This makes the convergence much faster and improves the accuracy. This table shows the results of ablation study. The unit only with EfficientNet B7 encoder achieves the comparable score to top 15 in public leaderboard. Applying watershed algorithm greatly improves the score compared to a simpler alternative used in the baseline. Ensembling unit models gives a moderate improvement. Post-processing with light GBA models shows only a marginal improvement. Here, we are showing some prediction results by our solution. The left one is input SAR imagery, and the middle one shows the predicted polygons overlaid on SAR imagery. The white polygons are true positives, and the yellow ones are false positives. In the right one, the ground truth polygons are overlaid on optical imagery. The blue polygons indicate false negatives. We are showing some more examples. This example shows a typical failure case of our solution. The neighboring buildings are detected as one polygon. Let me summarize our work. In order to extract building footprints from SAR imagery, we propose a solution which consists of three steps. Firstly, we compute building score map using unit models. Then, apply watershed algorithm to the score map to extract building footprints as polygons. Finally, we remove false positives with light GBA models. One of the keys is the choice of unit encoder. EfficientNet achieved the best score while having less parameters compared to other networks. Post-processing is also important. Watershed greatly improved the score compared to a baseline approach. But there still remains much room to improve. Our solution often fails to separate neighboring buildings. Thank you for watching our video.